Kia ora tātou, everyone. It's Bill here. Today I want to look at the responsive and reactive nature of our embedded system, our microcontroller-based system, also blocking code, and how we can use things called external interrupt pins to make our system more reactive and responsive. So the first thing I want to do is I want to have a look at this code here and have a look at what it does. So if one switch is pressed, we have this countdown. If another switch is pressed, we turn on the green LED. If another switch is pressed, we turn on the red LED. And if the opto is low, it turns off the two LEDs. So let's just see what happens here in our code. So if I press this switch, then the green LED should come on. That's what happened. The green LED came on. And if I trigger our opto sensor by putting a bit of white paper in front of it, the green LED goes off. So that's on, that's off, on, off. And we've got the same with the red LED. I've got both LEDs on, that will turn them both off. Now I'm going to trigger my countdown. Well, let's actually leave the red LED on and we'll trigger our timer. And so it's doing the timing now. And while it's doing the timing, it can do nothing else. So if I push this button to turn on the green LED, nothing will happen. And if I try and block my sensor, nothing happens. This is called blocking. So you can see in the code here, what's happening is once we're in this do countdown function, it never comes back to check these switches again. Let's just have a look at that again. So at the moment, I've got my red LED on, turn on my green one, and turn them both off. So I'm going to turn on my green one, start the countdown, and just show you that again, this red button, the button that turns on the red LED, does nothing. My green LED is going, this does not do anything. It's being blocked. Nothing can happen until the countdown is finished, and now I can reset my LEDs, turn them back on again. This is totally unsatisfactory in terms of a reactive and responsive system that we need. So what we're going to do is we're going to look at the pins in the microcontroller. If I pop back over to the pin connections here, zoom in, we have a couple of pins which we can use, we can connect external devices to, that will interrupt the current position of our program and force it to carry out some other instructions. And those two pins are called INT0, which is on D.2, and INT1, which is on D.3. And if we look at our diagram for this system, you'll find that switch 2 is connected to D2, which is INT0, interrupt pin 0. So what I'm going to do is I've got to figure out how to use these, and all of that information is in the data sheet. If I go to external interrupts, this looks at how to use them. And if I look at the registers, then there's the register description for external interrupt control register, EICRA, and these are for my interrupt 0. So if I just look down at this little table here, interrupt 0 sense control, I've got 4 different ways that my interrupts can operate. I can have edge triggered, falling or negative. I can have a logical change, so either so both falling and rising edges, or while it's low, it can continue to generate an interrupt. So at the moment, I've got some setups in my program. So I've got this code called INT0 init, which init, short for initialization, and there's a little function down here. What I've got is I've told it to set ISC01. ISC01 set to 1 means it's on a falling edge. So when the pin goes low, it's going to interrupt my program and go and carry out some different instructions. So now we need to have a little think about this program. Now, the instructions that it carries out are configured inside a little function called an interrupt service routine. And here's my interrupt service routine for INT0. And underscore vector short for vector, which means sort of jump here and do this. So go to this point and do this. And when you finish this, go back to where you were before. And all it does at this stage is it changes the variable count to -1. We'll look at that in a little bit more detail. I'll just go back through. Now this register values set up the sense, but it doesn't actually turn it on and off. There's a second thing you need to do, and you'll find that in the EIMS case, that's external interrupt mask. So here it is, the external interrupt mask register, and we must write a 1 into this INT0 for the interrupt to work. Okay, and that's it. Well, actually it's not it, because there's like a global switch for all the interrupts in the microcontroller, and it's configured using this SEIC command. I want to have a look at what's happening in, say, the simulator when I use this SEI command. So where's my function? Here it is here. So this is the function for initializing that. And we'll go to these registers and we'll have a look at the registers to see what's happening when we run this code. So I'm going to step through this code. I'm going to step through. The first thing, let's see, we better stop it first and step into the code. And the first thing it does is it sets all our registers to 0. These port input pins are actually high at the moment because those have got switches connected to them, so that's why they've sensed them as high. And as we step through the code, actually it's not going to work because I haven't uncommented this to do the initialization. Let's step through the code now. So there we go, it's about to jump into this routine here. Next step. Here we go, and the first thing it does is it sets ISC0 and EICRA. So EICRA is this register here, and it's set that bit. The next thing it's going to do is EIMSK, external interrupt mask, and so I need to look for that register. That's up here. So the next operation is going to set a bit in there, which it's done. And now the next thing that's going to do, this SEI, is enable global interrupts, and that's going to come down and set the bit, in fact bit 7 of our status register for the whole microcontroller. So I just step that, there we go, and it's set that. So now external timer interrupts, ADC interrupts, all those things are now configured to take place. So it's like a series switch on all the interrupts. It turns them on or off. So now to figure out how to get this to work, I'm going to go through the code in Atmel Studio, and I'm going to go through it, and I've put some comments in here. If I scroll down, you'll see where I got these series of asterisks. Uncomment this line to make the program more responsive. Okay, and I go down, and we'll just find, oops, there must be some of them hidden in here. All right, there's some hidden in here and in here. So here we go. Comment this line to make the program more responsive. Uncomment this line to make the program more responsive. So you can see what's happening here is I'm commenting out the delay routines in our normal functions, and I'm putting in my own delay routines. I've done the same down here. Comment this one and uncomment this one. So my delay routine is a little bit different to the standard function. Oops, I've got an error here. This should say beep, not tone. There we go. Now, if I go down to my function, my delay function, what happens here is it takes a value of milliseconds that I want to delay by, subtracts 1, and then waits for 1 millisecond. So instead of having a normal function which delays for, say, 500 milliseconds, what's happening here is I've created a loop which delays for 1 millisecond 500 times. So whatever I pass into this, it will delay for that number of times. However, after each delay, it's going to check the value of count. And if count is less than 0, then it's going to break out of my while loop and exit my delay function. So now what happens is, if I go back up to my, and I can just use my little split option here in Atmel Studio, and I can see my interrupt service routine. There's my interrupt service routine. Whenever I press the button, count is set to -1. And so down here in my routine, it might be merely counting down 499, 498, 497. But at each stage, it's also checking to see if count has been set to less than 0, at which case it will break out of the function. So now I've found a way to make my program more responsive and reactive. So I'm going to compile this, see if it compiles. It's compiled. I'm now going to plug it in, and there we go, and I'm going to upload my program. There we go, verified. And now what I have is I still have the capability to turn on my green LED and turn it off, and turn on my red LED and turn it off, and start my timer. But while it's doing that, I can interrupt it and stop my program. So now I can cease my program anywhere during its countdown, and I can then start it again. I'll just stop that. So now my program is more responsive and reactive than it was before. So this is how you might use an interrupt, an external interrupt, just to stop whatever's happening in your normal program from happening, go away and do what's in your interrupt service routine, and then jump back to your main program. So setting a flag in an interrupt routine is a very common thing to do. You wouldn't put a lot of functionality in this. You would leave the functionality in your main program and just check your flags to see what's happening. So I hope this helps you understand a little bit about external interrupts. And if you had this board at home and you might want to experiment with it, you could create some interesting features using that sort of thing. Cheers.